Rightio, g'day students, welcome to today's lesson on similar figures. So the point of today is that we want you to be able to calculate the scale factor for similar figures and to use similar figures to find the unknown length sides. Now the key idea for today is that similar figures are identical in shape but can be different in size. So what does that mean? Their sides are in proportion but all the angles have got to be the same. So for two figures to be similar, all angles must be equal in sides, and all corresponding sides must be in the same ratio. Now, if two figures are known to be similar, then an unknown side length or an angle can be found if the scale factor is known. So the scale factor is calculated using the formula. The scale factor equals the image length divided by the original length. Now, to find an unknown side length of an original figure, use the formula. Original length equals image length over scale factor. To find an unknown side length on an image figure, use the formula. Image length equals original length multiplied by the scale factor. Now, scale factor can also be written as ratio scale. Now, for example, a scale factor of 1 to 10 is the same as a ratio scale of 1 is to 10. Just going to pop over and have a look at the e-tutor, and we'll just explore this a little bit. And we're just going to have a look here. Now, to consider if two sides or two objects are similar, we're going to have to look at the scale factor of each of these. So here we've got the original. In this case, the original is 10 centimeters and this is 2 centimeters. So this is 1/5 or 0.2. So we've got a scale factor of 0.2. Now let's just explore this side. If it has a scale factor of 0.2, well, yes, they must be similar. Remember, similar figures have sides that are corresponding sides in the same scale factor and have equal angles. So let's try another one. So this one, 6 and 12. So you can see that these two are corresponding sides. And this has a scale factor now of 2. You can see that the image is twice as big as the original. Let's have a look at this one. That's 6 centimeters. Yes, that makes sense that the image here, 6 centimeters, is twice as big as the original. So it's got a scale factor of 2. Now let's look at this one. The image here, original has 4 centimeters, but the image has 5 centimeters. We've got a scale factor of 1.25. So no, those figures are not similar. Let's do one last one. So here's our original, 24. The image has 12, so it's got to be a scale factor of 0.5, hasn't it? Now let's have a look over here. Yeah, that looks right. The same scale factor of 0.5. So yes, that they are similar figures. Okay, I'd like you to have a go at this one. You can get in there and work on that one. And I suppose we should also have a look at a guided example. Now, given that these two figures are similar, let's find the value of this pronumeral. So the pronumeral is this little x down here. And you can see that this side here, DC, corresponds to YZ. So we're going to have to use a scale factor to try and work this out. So let's go through our example and let's see what the question is asking. So let's identify a pair of corresponding sides on the original and the image. Now, if the two similar figures are similar, they must have the same corresponding sides in the same ratio. So if the first shape is the original shape, so that's the original, and we look at the side length AB, so AB, what is the corresponding side on the image? Well, that's got to be the longest flat side. So that's got to be corresponding to WX. So let's find, oh, that's nice. Let's check my answer. Oh, that's good. I am correct. Let's go to the next problem. Now we can use the corresponding sides we found in that AB and to WX to find the scale factor. And so what do we say? It's 20 divided by 5, so we've got a scale factor of 4. So the scale factor equals the image. In this case, we've got 20 divided by the original, 5, so we've got a scale factor of 4. Now, identifying the corresponding side for an unknown side, so if the pronumeral x as side length here is CD or DC, is part of the original shape, then the side that is corresponding to the side of the image is, well, let's have a look, that's a bit like a dog leg, isn't it? It's a bit of a bent line, so it's got to be corresponding to this bit, and it's got to be Y and Z. Okay, let's have a look here. Which formula would you use to find the missing side length? Now we want to find the original side length, don't we? So we want to find that one. So that's good. And then let's do our substitution. So the original, which is x here, equals the image divided by their scale factor. So here's our image, and we're thinking of YZ, so it's 12 centimeters. Now we need to divide it by a scale factor of 4. Now 12 divided by 4 should equal 3. Woohoo, I can do something correctly. Okay, so that's how we can do that. Let's just have a look over here at our worked examples from our textbooks as well. So what do we want to do? We want to find a scale factor for this pair of similar figures, and we're going to assume that the first figure is the original. So let's just have a look at the question, and what do we want to do? We want to find the scale factor. So that's the first thing. So we just need to find some corresponding sides. So I can see that this side and this side is corresponding. What else can I see? I can see that this one and this one correspond to each other. They correspond, and the others correspond as well. So now we've got some corresponding sides, and we just want to use our scale factor formula, which is image length divided by original length, to find the scale factor. So we can use any of those sides, and I just want to find one that's going to be easy. So the image length, let's say 5 divided by the original length, so scale factor equals what? Image over original length. In this case it's 5 centimeters over 15 centimeters, and that's going to be, let's cancel out in the fractions, that's going to be the same as a third. Now we can prove that in a variety of other ones, so we can just keep working around the these two shapes, for example. So let's find some other corresponding sides. So let's look at this one and this one, and that's what just going to be 4 over 12, and 4 goes into 12 3 times, so that's going to be a third. And let's find another one. So we've got a 9 and a 3. Well, that's 3 over 9, which is the same as saying 1/3, and so on. So we just need to make sure that all of those are in proportion if they are going to actually be similar as well. Okay, now the next one is just going to say, given that the two figures are similar, find the value of x. And this is what we did on our worked example, isn't it? So first of all, we've got to work out our scale factor. And remember, our scale factor formula is the image length over the original length. So let's just find some corresponding sides. They look nice and easy, so we'll do that one in. So the scale factor equals original length and image length, so it's 10 centimeters for our image divided by 2 centimeters for our original, so we have a scale factor of 5. And then what do we want to do? We want to find our unknown, which is generally called a pronumeral in here. So remember, a pronumeral just has a symbol. In this case it's the letter X. So what we're going to do now is just find the original length. So the original length equals what? The image length divided by the scale factor. And it's been a little while since I've written on here, but you just go, oh, well, what is that? Well, it's 15 is our image, so 15 centimeters divided by our scale factor, which we worked out there. So 15 divided by 5 is 3 centimeters. I'd like you to work on your mastery exercises now, please, folks. And 10 minutes before the end of the class, do the multiple choice O-book assess, please.